we haven't officially started, but I'm kind of curious. How many of you have done something with LLMs or AI, but not just using ChatGPT? Like, that's how many of you have made a call to an API to an LLM? All right, you do not belong in this session. Thank you very much. That's good. How many of you feel like you don't know where to start? All right, well, I'm in your camp, so we're in good company. I know this says it's a technical deep dive, but the pool's pretty shallow, so we're going to go as deep as the pool.
Floaties.
Yeah, floaties. I like that. Anticipation. All right, we're waiting, so I'm going to get vamping. All right, a couple things and a couple caveats. I do have recordings of a lot of these things, but I'm choosing today at the very last minute to do this live, right? And that is fraught with all kinds of issues, as you all know, right? So if things go really south, bear with me. We'll kind of fight through it. We'll see what happens, right? We've got internet gods. If you have any sort of religious affiliation or that you choose to share with me at this moment, then please feel free to. All right. So we're gonna do some live internet things and so forth. And what I'm really hoping to do is spend time in code as much as possible, and that's going to be tricky because the screen is big and the code is small, and so we're going to have to fight through this a little bit. Is that cool? And if this doesn't work, just come see me later, or you come up here and we'll just hang and have fun and we'll talk about cool stuff. Is that good? All right. That's the contract. I've already told you the deal. You're all bought in right now, right? Cool. All right, let's go. All right. So welcome to AI Foundations for Claris FileMaker developers. All right, the focus here is going to be about AI and FileMaker, not Studio, not Connect, although those things will have some impact in all of our futures. But I'm going to focus mostly on FileMaker as the premise. A little bit about me. I am Ernest Koe. I'm the CEO of Proofgeist. And you can find me at the booths if you want to. Come later. And again, to level set, this whole thing, it's about getting started. All right, if you really want to get deep, you don't need me to teach you how to do that. You know how to do that, right? You can ask ChatGPT. It's a very good teacher. You go to town. Right? My job here is to give you a good foundation, a groundwork, and to cover some core principles and core concepts to get you started. All right, and some of these will be kind of simplified. And so if you really want to get into the nitty-gritty of things, again, I really encourage you to go and do your own research, and I'll point you to some resources that are really important. Right? And what I'm really hoping to do here is do this by way of example as much as possible. But this is a very big topic, so I have to cover some theory, so to speak. And I'm going to try to do that theory. I have like 30 hours of material that I'm going to condense to 30 minutes. So we're going to see what happens, okay? All right. So here's the setup. We're bored at Proofgeist, and we've decided our next product is going to be, I don't know, a movie rental online subscription service. We're going to call this Autoflix. This is not real, don't quote me. This is just the and we figured, hey, this could be a really great idea. Like, what if you could come and so I can see this is already a problem because my screen is so small I can't even see my tiny screen to do things, but we'll see. Imagine if you had sort of a video subscription database. You can see I've got 46,000 records, thereabouts, yeah? And I've got all these movies in here, and we want to build a thing where we can build a chat assistant to help our users navigate this catalog of awesome movies that we have on the database. Cool? So let's see how that works, all right? Oh, let's make a new session. Let's see. I'm going to turn on text to speech. Is it going?
Hello, I'm your AI assistant for Autoflix.
here to help answer your questions about movies or anything else you're curious about. How can I assist you today? Perhaps you'd like to know what the top-rated movie in our database is, or maybe you want to find out more about a specific actor's filmography.
Oh, that's pretty cool. Well, that's kind of like ChatGPT stuff, right? But it kind of knows something about autoflicks. Like, how did that happen? Like, it has some kind of local awareness. Like, what's going on here? Let's ask it some questions. What do you want to know? Let's see. Who's got a favorite actor or director?
Tom Hanks.
About Tom. I don't like him. I think I've removed Tom Hanks from the database, but we'll see. I don't actually know. I don't even know Tom Hanks is in here. Let's see what Autoflix tells us. And so some caveats as you're seeing this. What I've opted to do here is to do most of this, 99% of this, almost 100% of this actually, in FileMaker. So this is all.
Tom Hanks is an American actor and filmmaker. He is known for his comedic and dramatic roles in films such as Big, Forrest Gump, Saving Private Ryan, Castaway, and The Da Vinci.
You get the idea, right? So and it goes on and it talks about more and more and more. Right, that's pretty cool. Again, some caveats here. So what you're seeing here is actually a live, this is a real FileMaker database. All this code here is almost 100% native FileMaker. I've chosen not to do any JavaScript. There's no Python, no fancy microservices running in the background. This is all in the current, yes, in the current version that's shipping now that you have in your hands. Okay? So this is now all possible. And it's talking to my database, it has some kind of awareness. But this is cool, but what if I really want to do stuff like, hey, what movies do you have in the catalog featuring Tom Hanks? This is always dicey. I've never asked this question before, so I don't know what's going to come back. But I'm going to say, please keep it short. That's good. Very good. Okay.
Here are the top 5 results in the Autoflix catalog. Tom Sawyer Holly, The Movie Otto, Denoya Film Otto,
I don't think that's right. I don't think that's right. I know better than ChatGPT. Well, let's try Tom Cruise, okay? Maybe he likes Tom Cruise better. Let's see what happens. Just to be clear, I only have 45,000 movies in this. So again, I think I actually deleted Tom Hanks from the database. So let's see what the Tom Cruise is. Yeah. Let's see what happens here.
Why the llama?
Llama Meta AI.
Here are the top 5 results in the Autoflix catalog. Mission: Impossible Cocktail Vanilla Sky War of the Worlds My Scientology Movie.
That's pretty cool, right? So it's actually looking into the Autoflix catalog, understanding that I'm asking it about Tom Cruise, state actor, and pulling up information directly from a database. Again, 100% native code here. What's going on? And then you can do things, interesting things like, hey, maybe I can see the results, right? I was surprised. This seems surprising, but if you look at the actors, look at that. Tom Cruise is in here. So that's interesting. All right. You want to know how I do this? All right, that's pretty cool, right? Okay. Can you guys see, like, imagine a way you can incorporate AI into your application? So this is what we're talking about here. All right. So let me switch back to the slides over here. All right. So we've got a database, we've got Autoflix, can ask questions, can do stuff, and I don't want it to play. I want it to go here and let's see here. So we're going to start from the very beginning. Very good place to start. It's not my quote, it's Julie Andrews. And let's start with the very top. What is generative AI? So I think you're going to hear this a lot. You're going to hear that, oh, we've had AI before. And that is true. We've had AI before. This is not the first time that we're encountering AI in the ecosystem. If you've ever played with Core ML and FileMaker, FileMaker's always had support for since FileMaker 16, I believe, Core now, right? For AI. Right. So you can think of LLMs, and what's new here is that we have this ability to interact with an AI using sort of a natural language interface that is new, that we've never had that before, right? Since the last year and a half. So, all right, so but when we're talking about AI, I'm actually talking not about the stuff that's come before the past, which is the foundation for a lot of things that we've done before. I'm talking about this like novel aspect of AI that we're now seeing, which is our ability to interact with it using natural language. Does that make sense? All right. So when you go around and say, hey, AI, and people say, we've had AI before. I think this time it's a little different. This is something new, right? It gives us access to a way of thinking about and using machine learning that we've never really had access to. All right, the question is, what do we do about it? All right, so some basics. Again, AI, big, vast field. There are lots of different models out there, lots of different algorithms, essentially programs that understand how to deal with data, essentially make predictions. And LLMs is what we call a large language model. Is this one variant of those things. Now, it's a special kind of AI model, but it is one form of an AI model. Right? And outside of the LLMs, you can actually use AI today to do AI models today to do all kinds of stuff. Right? You can create pictures, you can do keyword analysis, train it to do things, all kinds of interesting things. All right. The question is, have you guys done anything with Hugging Face models and open source models or Core ML? Well, if you haven't, hopefully this will be an introduction not just to LLMs. It'll be an introduction to a gateway for you to look at all the vast space that is AI. And that's very cool. All right. So a couple of things that are important with you. Okay. The way large language models work is that, there's a lot of language here, but the basic idea is that they've trained this program on a vast array of data on the internet, public data. And it has a capability of understanding natural language and interpreting natural language and spitting back out results. Okay, that's kind of like the GPT aspect of LLMs as we know it. All right? And for me, they are a game changer. Right? And they're a game changer because for the first time, we've had access to a way of using AI that I don't think has been easy or particularly interesting or fast before. Right? This gives us a way of accessing models in a way that's kind of new. But here's what's important. Right? Is AI magic? Well, it's mostly, I think, a predictive engine. So it's statistics. But it's very, very good at what it does. It's very, very good at what it does because it's trained on a very large data set, and it understands not just words or keywords, it understands sentences and paragraphs, and that's kind of that's one of the underlying foundations for its magic, right? So it can take a sentence and it can kind of interpret it for you, and it knows how to kind of understand those sentences because it uses vectors that are built on many, many, many dimensions, right? What are dimensions? Just think of dimensions as fields. Right, so the key power here with AI is that it's not just understanding, syntax. It's really understanding the relative meaning of a sentence or word, of tokens in the context of all the other things that it knows before. So the simple way to think about this is that it's just autocorrect on steroids, right? Makes sense. So it's not so scary after you think about that, right? So when you do autocorrect now, it gets a lot of things wrong. Right? And in the LLM world, it's going to get some things wrong. But what it's fundamentally doing is it's making predictions based on known data that it's trained on. Cool? Okay. So the core concept here is AI is smart, but it's really freaking dumb. Right? And it's freaking dumb because it doesn't know anything about your data. Its knowledge is non-local. Does that make sense? But it knows anything that it knows that it can spit back at you. It knows because it's been trained on. Right? Now, people might argue that, well, you can get really creative. You can make poems, you can do new things. But it's actually using a predictive capability that's built in based on its training model to do that kind of stuff. It doesn't know any knowledge about your specific database. Right, so you're going to do, if you chat GPT something about your data, about your business, it doesn't know any of that. So it's very dumb. Right? The question is, how do we take advantage of the smartness of LLMs and AI against your local data set. That's the magic, right? Then we can see that, hey, we've got some power here. No. So I'm going to talk about 4 things here, and these are like what I call the building blocks of getting into LLMs, right? But I want to underscore one thing before I get there, right? LLMs are powerful because they deal with natural language. It's also an interface to LLMs, right? We're actually kind of programming and interacting with it with text. We're typing, we're using speech that gets translated to text, and that becomes the basis of how it makes further predictions from its model. Does that make sense? Okay. Now, models, right? Again, if you play with AI at all, know that ChatGPT is one set of models it's got, and that's by OpenAI. But there are actually thousands of models that are out there. A lot of them are open source. If you're going to start playing with this, just check the licensing terms on those models. Some of them don't allow commercial use. Some of them are restricted. But if you go to huggingface.com, it's like this marketplace of models you can go research and download. It's pretty freaking awesome. You know, there are other things like this, like LM Studio, I believe, which is fairly new, that has some pretty cool models that you can just download to your desktop and play with. All right. So models are basically just like these engines that you use to do your AI work. And different models do different things. Right? So if you want a model to work with images, go get the model that works with images. Right? You want a model to do translation, you can find a model to do translation. So there are thousands of models out there to do different kinds of things. ChatGPT, the GPT model, is a conversational chat model. That's kind of the power of LLM Exposed, right? They're giving us a way to chat against basically the knowledge of the world as we know it. Okay. If you know nothing else today, all right, get this point. In order for LLMs to work against your existing data, we have to turn it into a language it understands. All right. And LLMs actually don't speak English. They actually know nothing about languages as we know it per se. So when we type something into the text input screen and we say send, in the background it's actually doing some kind of encoding to turn into a stream of inputs that it understands. Right? And those are vectors. Okay, and what's a vector? A vector is basically a silly math term for a set of coordinates. Right, so corn here, you might say it has, I'm going to vectorize corn and give it 2 dimensions. I don't know, height and, just to be funny, weight. Okay, and so you can think of corn now has 2 vectors, and I can look around the room and say, well, all of you can be sort of coordinatorized, put into those 2 vectors in some way. You could be, 5'9" and 120, and so forth and so forth and so forth. I'm using American vectors, so not English ones. So a vector is just a dimension in space. Right? And as database people, you get that, right? So they're just fields and properties, really, right? So if you look at your traditional database and you say, well, how many dimensions do I have? Well, it's basically just the properties that you store against your table, in your table, right? It could be name, phone number. It could be qualities of that person, whether they're funny or they're happy or they like ice cream or not. All those things are dimensions in a possible vector. Right? So LLMs actually understand the world by converting those vectors into basically a string of coordinates, a set of coordinates, and they're making comparisons based on that. The power of LLMs is that they're doing this at a very, very, very large scale. So, I posted this number before, but GPT actually has something like 12,000 dimensions for every single token that they have in the system. So for every single word or thing that they can analyze, it has a semantic way of understanding semantic proximity to other things in the universe across 12,000 dimensions. That's how it makes those kinds of predictions. Okay? But vectors are important because in order for us to use LLMs locally, we've got to get our data into some kind of vector format. And that's going to be a foundational thing you do with a lot of AI exercises with local data. Right? So we're going to talk about this. This simple vector, you can think of these things as being compared across just two dimensions, in this given size and color. And with LLMs, what you're doing is you're taking some kind of text and you're putting into an embedding model, using the embedding model, and you're spitting out a vector. And this is as text. It doesn't have to be stored as text, but this is a text representation of the vector. So far, so good? All right. So it's just math. It's just math with a string of coordinates, essentially, for the most part. Right. LN vectors are really deep. So you can look at a vector space, kind of like this is actually not a GPT vector. It's actually a more simplified vector. It's going to be small. But you can imagine this as a 3D visualization of what a vector space might look like for a data set. Right? All these points and spaces of how things are related to each other in relative coordinate space. Right? And I know this gets really geeky, but this is important because a lot of what we do with our data in our databases is about figuring out how far one thing is from another for similarity comparisons, right? Whether Tom Cruise is in my database or not from a semantic level, I'll talk more about that later. It's really about how close does that match the data that's in my database, that question that I ask, right? So it's making a fundamental comparison. And that comparison is a similarity distance problem, which is just looking at two vectors and comparing sort of the cosine distance, right? That's the end of the math lesson, right? That's all you ever would need to know about LLMs and math, right? But you know that you're in very, very good shape, right? Now, this is actually an example of a real live embedding that I did of a record of some 15 dimensions, some 15 fields and some text data in my database. Right? So these things get really, really large, right? It's not something you can read with, in person. Now, the next thing you got to do, you may have heard about this before, right? In order to work with LLMs, today anyway, this will change tomorrow, I'm sure, right? Today, you need to understand a little bit about prompts. And prompts are a way of preparing your AI engine, your model, to give you a response in a way that you want. So it doesn't really know what your intentions are. It can guess, but the more you can prepare it to know what your intentions are, to expect that, the better. So prompting is going to be a very important component of everything that we do with LLMs, again, today. What's coming down the pike is some really cool things. We may never need to do prompts again, but for now, you got to do prompts. And here are a couple of examples. So I may actually show you this, but this is an image generation prompt. So I'm feeding it all the things I want it to create. And the better I'm able to curate those prompts, to craft those prompts, the better my results are going to be. Right? And this is true for a lot of AI applications, including things like search and semantic search and so forth. Right? This is an actual prompt, a chat prompt, that I'm going to show you guys later today. Right? And this is actually all in FileMaker. Can you all read this? Yeah. So if you're new to prompting, you may be wondering, wow, what do I know what to say? Right? And it's going to take a little trial and error to get the prompts just right the way you want it. But really, in my experience, once you get into it, you kind of get a hang of it, right? You kind of understand the limits of what it can kind of respond with, and you're going to have to shape it to tweak the outcomes in just the right way. Now, again, this is not like a database operation. It's not about precision, right? If you want precision, you have other tools already today. And you don't need LLMs and AI to do this, right? This is about the ability to create a predictive response, a more natural response. Right? The last thing here, and then we're almost done, is tokens. All this stuff takes tokens. They take text that need to be fed into the AI model. And using standard AI models in the commercial space today, like OpenAI's models or whatever, sometimes there are token limits that you have to be aware of. And so a lot of our applications, when we work with local data sets, that we have a lot of data we're kind of pushing back and forth through the internet, right? And into those AI models. And you can do that, but there are limits to how much you can do, and sometimes it gets really expensive. Right, so token management, the size of the package you send upstream is going to be important. And that sort of informs everything that you do and how you break out those chunks of data and how you manage them in your local data sets. Right. All right. Everybody good? Any questions so far? Okay. Yeah.
So that example you showed where you had like 15 properties in a record, all the numbers on this one, is that a relative or an absolute dimensional list of properties? Like I'm curious if you want very precise numbers.
It doesn't actually matter. I mean, in terms of what we store?
Yeah.
Or in terms of how the AI translates it?
However you want to answer it. I'm just curious, like if you take a piece of that same data, process it through a different model, would you get a different set of dimensional properties?
Yes.
So it's the model that determines the...
Yes. So that's exactly right. So the model and how it's trained determines how it vectorizes the data. All right, so which is why if you use different models, you may get different results. Even if you use the same model, you might get different results. But chances are, if you use a different model, it will have a different vector space for any token that you give it or a set of values that you give it. And this is why things like domain-specific models are really powerful, because it's trained to make predictions that's specific to that domain. So it doesn't apply to say, if you can do an LLM that's about automotive repair. That's totally different than, say, prescription analysis or whatever you want, right? Other questions so far? Good. All right. So before I dig into the actual code, let's talk about training versus inference. This comes up a lot. Sometimes when you look out in sort of the AI space, you talk about people saying that we need a lot of GPUs to do stuff. We have to train all these new models, and it's very expensive, and so forth and so forth. Well, I want you to think about the AI space as kind of separated in two problems, right? There's making new models, and then there's just kind of using the models. Make sense? So the first part is training. That means you've got your own data set, and you want your own custom AI model to get your results that's specific to your data set, right? And you're going to send it inputs that are specific to the data set. It's going to spit you, get your responses that are specific to it, and that's called training, right? The other side of the world is called inference, which is we're just using something and making sure that it's inferring from the data that we are that already exists. Cool. Right. And then there's a shade in between called fine-tuning, right? Which is not exactly training from ground up. It's like taking an existing model and you are just tweaking it so that you get better results out of it. 90% of what we're going to be doing is going to be inference. And that's because training and fine-tuning can get really, really expensive. I think Bloomberg spent something like, I don't know, $12 million on some kind of training exercise for the LLM that they're building, right? So it's really not accessible to most people. Right, should not mean. Right, so most of what we're going to be doing is just leveraging existing models and getting the most impact out of it. Right, so you may be wondering, well, if I can't train the model, how does it know anything about my data set? That's the conundrum. Right, if it's too expensive, I have to spin up all these GPUs. And by the way, GPUs are running low. It's actually hard to get. We spun up a GPU, a couple months ago, and it's like a couple $1,000s, a month just to keep this little dinky thing running. It's pretty expensive. Now, prices will fluctuate and change and whatnot, but training may require hundreds of GPUs, hundreds of hours to build some big models. Fine-tuning a little less. So again, most of what we're doing here is about leveraging inferencing exercises. Right? And we can do a lot. We can do a lot up to the threshold of having to train a new model. So this is all good. This is not a bad problem. So if you're thinking, oh, I need to get an AI, I need to start doing training, you don't really need to. You're mostly doing inference. Okay? All right. All right. Any other questions before I dig in? Good so far? All right. So let's look under the hood. Okay. So let me go back to my little app here, and I've got this chant thing. And let's kind of break it down and see what's going on. So what's happening here is I've got an interface, and I am typing in some kind of question. I'm hitting send, and it's getting back a result. Right? So what's actually happening here is, again, all this is basic FileMaker. I'm taking this input string, and I'm literally sending it up to an OpenAI endpoint, their API. Right? I'm going to show you how to do that just in just a second. Right? One thing to say about this is that you don't actually have to use OpenAI. I mean, you can use any LLM you want. I'm using OpenAI just because it's easy. It's kind of brainless. But there are tons of APIs out there, and they're actually models that you can kind of install and use yourself. Right? So big picture, I'm setting it up. It's getting me a response, but it still doesn't know anything about my database. Right? It's just doing general knowledge. So if I can ask it a question like, I might get this wrong. I haven't tried it. What is 1 + 1? See what it says. I might say 11.
The sum of 1 and 1 is 2. Would you like to ask another question? Maybe about another basic math problem or a different topic entirely?
This is non-local information. Right? This is stuff that's in the world. If I ask it something like, what movies, I don't know. Show me, let's see, dogs and cats. Right? That's a more interesting question for your local data, right? So what does it have to do here? So it's going to have to take that question, translate it into some kind of...
Here are the top 5 results in the AutoFlix catalog. The truth about cats and dogs, cats and dogs, cats and dogs. The revenge of petty little dogs. Pause.
And by the way, this is just my text-to-speech from my computer. It's not any... There are OpenAI text-to-speech engines you can use, and this is just me being cheesy. Right? But here you go. Here are dogs and cats, and I got my top 5 records and so forth. And this is pretty cool, right? So it has some kind of knowledge about my internal database, and how does it go about doing that? Well, first thing first, I'm actually doing a search. That's the fundamental exercise, right? I'm executing a search in FileMaker, but I'm not doing a keyword search. I'm not looking for dogs and cats as text keywords that I'm searching on. That's very, very fast. I'm actually asking a different question. I'm asking what kinds of movies that are in this semantically related idea of dogs and cats. Right? And that could be a very, very vast repository in my database. It can be just dogs and cats, it can be dogs without cats, it can be dogs and cats with anime, all kinds of stuff, right? So, and it could be searching against data where there's no mention of dogs and cats at all in my database. Now, I've only returned 5 records here in my results because I kind of limited that, but you can obviously return any range of records you want in the search. So that search is called semantic search. And this is something that you'll wind up probably doing quite a lot with AI in your systems. Now, just to be clear, if you really just want to find things fast, LLMs are probably not the way to do it. Like a lot of use cases for LLMs, you probably don't need LLMs to do. But for things that are about proximity, about semantic ideas, about meaning and not keywords, then it becomes really interesting. Right? Because it gives the user a way of interacting with your system, but they don't really fully have a well-formed idea. That's what we're going after. That makes sense? So I haven't answered the question though. So what is it actually doing under the hood? Like, how am I doing this semantic search? Now, 2 things. All this is happening locally. So even though I'm using OpenAI, I'm not sending my data out into OpenAI's databases. Right? That could be a scary thing, right? If I send my PDFs and financial statements out to OpenAI and say, hey, tell me about my last 10 years of P&L and whatnot. I don't want to do that, right? This is dogs and cats, so it's low risk, but it could be high risk with some of your business data. But we're not actually doing that, right? What we're really just doing is taking the prompt that we constructed, have the LLM interpret my intentions, and then using the result of that to do that search internally. So I'm actually applying AI locally to my database. And this is how I'm doing it. So first, I have to create a screen that works. Here we go. I have to perform a semantic search. Again, semantic search is a search on meaning, not on keywords, right? And I'm taking a bunch of data in my database, turning into a document, and then I'm vectorizing it into a vector data store. Does that make sense? So step one. And I have to do this because in order for me to use an AI model to get approximate meanings, I have to encode it in a way it understands. Right? And you can do that not just with text, by the way. You can do that with songs, with music, with anything that you have in your data set. Right? Because at the end of the day, it's just turning into a bunch of like coordinates, numbers. Now, I'm showing this to you as text, but it doesn't have to be stored as text, just to be clear. In fact, you would typically store it in the vector database. Right? So the early versions of this demo was built with a vector data store called pgvector. Okay? And if you're getting into this, the one I recommend playing with is Pinecone. It's got a built-in API. It's easy to use. It's pretty cool. And I don't know how much it is, but it should be fairly affordable.
Are the vectors universal?
Say more about your question.
So if a word is represented by like one of those strings, is it the same for all the models that each model would interpret the vector?
Not necessarily. Okay. In theory, it would be the same from model with, if you use the same model for the same set of text, in theory, it would be the same, but with caveats.
So these vectors are model specific.
They are model specific.
That's what I was.
In fact, the model is right up there. So I'm using a model called text embedding ADA 002. Right? In fact, when I click this button, create an embedding, that's literally what I'm doing. I'm calling a function. I'm returning the embedding. And I'm actually calling that function, and this is where I'm going to turn on script. And I can't actually read my screen, so we're going to have to create embedding AI model. There you go, look at that. If you take out my comments of code, it's like 10 lines of code. It's not, this is very basic stuff. Like I'm not doing like magic in FileMaker. What I'm really doing is I'm, what am I doing? So I lied. I'm actually doing something pretty cool because the early version of this was built with standard insert from a URL, right, which you can do today. Well, what I'm actually doing here is using what's in the ETS build. So remember what I said about, hey, you can do this today? Yes, you can. But this is way easier. This is way easier. Same principle though, right? All I'm really doing, so what again, I gotta kind of pull out my caveats and all that stuff. I don't know whether this will make it to production. I have no idea whether this is, this is all prototype, pre-production, kitchen.
Flagrant violation of ETS.
I asked you for permission. Good, there you go. I rewrote my slides last night after I got this. And I'm showing you this not because I think that FileMaker needs to do this natively, but I think it's really cool that that Claris is taking this pretty seriously. Right? So now we can do a lot without any of the support. We can do this with standard insert from URL and all the cool stuff. You can do that today. Right? But I'm showing you this example based on embedding a script step that's actually built into the code base in ATS. But again, the principles are the same. They're actually the same whether or not you do this in FileMaker, you do this in Postgres, you do this in any other database system. You got to create an embedding and stick it somewhere, right? So I've created an embedding and I've stuck it somewhere. Now, where did this embedding go? Well, originally, it went to pgvector in the Superbase database. It went to Superbase database in the pgvector store. In this demo, which I rewrote, we're actually storing this as FileMaker vector embeddings. And if you go to Ronnie's session, you go to some of these sessions, this may come up, but a vector embedding is just a bunch of numbers in a field, indexed in some particular way. Right? Why couldn't FileMaker be a vector embedding store? No. So if you think about that, now your local data has, sure, you could do the code, you can push it, you can upsert it to some other database and then do your queries against that and get the results back. We all can do that, right? It's a pain in the butt, right? If you do this all in FileMaker, that'd be pretty wicked cool, right? So that's exactly what's happening here, right? So I'm doing all this in FileMaker. I'm creating vector embeddings. I'm storing it, and I'm actually storing this literally in FileMaker. And then I'm going to test this, right? So let me get stories about adventures at sea. I'm going to do semantic search against my 45,000 records. It's pretty zippy right now. Again, this is not even optimized stuff. Like this is like, hot off the, the press and all that. And I get 10 records back, and look at that.
About how long does it take to get the embed back?
Milliseconds, very, very fast. Again, the bigger your prompt, the longer it takes.
So are you searching that cosine distance field and looking for high value sets?
That's exactly it. So if you don't search, this is very similar than stuff that we used to do with like full text search. Except again, we're not searching on keywords. We're not doing like some fancy Levenstein distance on word distances. The distance concept is the same, but it's a cosine similarity distance against a bunch of high dimensional vectors.
And just to follow up so that I understand. So that embedding you only had to do once.
So the question is, that embedding I only have to do once. And the answer is yes, thank God.
And so then every search you do is just that cosine distance researched.
Yep. And literally that cosine distance is right here. So let me blow this up. Right. So you are locked on to this idea. So this tells me that this record is 0.83 whatever relative distance away from the other things that are in my database. And if you look at the result, it's pretty wild, right? Like, so I did stories about adventures at sea. I didn't specify like, oh, this has to be Captain Ahab and Moby Dick, and it's just pulling up stuff that, hey, you notice that this is about ships. Yeah, sure. This seems right. And all that's because it's taking this prompt, this question, converting into a vector and comparing that vector against my vector in the database. See what's going on there? Yeah.
So just one final question.
Yes.
So you did send a request when you click that semantic search to the same model that you had used for your training, right?
So I did, but in this demo, I didn't. In this demo, I'm doing that semantic search natively in app. So again, I don't know whether this will make it. Again, you can do this without FileMaker, but there, in this example, there is a semantic search function called LLM semantic search. You don't have this yet in the production.
That's
product.
cheating.
It is cheating, and I'm proud to be cheating. Because it took me a month to get this right. Without this, it took me like 2 hours, to fix it. Yes,
You're doing inclusive search. What about anti-searching for finding the nulls?
You do an omit. I'm being kind of cheeky, but vector semantic search, again, let me back up a second. How are we doing on time, by the way? Good. We're in the meat of things now, so just keep asking questions. I'm going to try to show you code as much as I can, right? So the question was, how do you do the the negative? So again, semantic searches are just one use case. It's a very good use case for AI models and LLMs because it represents a lot of the power of what you can do with this stuff. Right? But it's just one kind of thing you can do, just to be clear. But if you are going to do semantic search, it's not a keyword search. It doesn't actually know anything about your data from a precision standpoint. Right? It's just predicting what matches. So there's some good use cases for this, but it's not like a panacea. It's like, oh, I'm going to turn all my searches to semantic searches. Please don't do that. Right? I'm not here to tell you to do that. there are much faster ways to do searches in most use cases. But for use cases that are about giving user this natural language experience, this is pretty
When using ChatGPT in a traditional sense, there's a certain memory that it has from question to question.
Yes.
Do you have the ability to sort of enable or disable that kind of feature?
Yeah, so the question is, when you use ChatGPT through the ChatGPT interface, when you type the question, it kind of remembers, like it looks like it's stateful, is sort of the geeky way of talking about it, right? Like how does it know whether my last question was related to other questions before it? Well, the bad news is the OpenAI endpoints and most models don't actually retain state. It's rest. You send it something, it's forgotten what you said before. It's dumb. Okay. So in order to make it look like it's smart, you got to keep sending it all that stuff all the time. Right? Now that's actually what the interface is doing. It's just remembering a history and sending it up every time you ask a question. So it has sort of a window of memory, so to speak, to kind of reference what you asked it. Now, the reason I can do stuff like show me dogs and cats and actually what is going on. Refine that search. I don't actually know if this is going to work, but we'll see. And it's not even proper English at that, right? So we'll see what happens.
Here are the top 5 results in the Autoflix catalog. The Adventures of Milo and Otis Cats and Dogs, She and Her Cat, Their Standing Points, Adam and Dog.
Yeah, kind of okay, right? But I use this example because I didn't repeat dogs and cats in my query, right? It somehow remembered that I asked it about dogs and cats. This is what I'm talking about, how you leverage an LM experience. And what's actually happening behind, I got you, what's actually happening behind the hood is I am storing a chat history. See that? I'm storing a chat history about what I asked it and what it gave me back. And then I'm sending bits of that back in each query. All right. So again, this is going to be one-on-one stuff that you do all the time. You're going to get so sick of it because, why don't we just have a module to do that? We got you covered at some point in the future. All right. But this is what you have to do. You have to send it. So this is like a sliding window thing. You say, I'm going to take the last 6 responses back and kind of keep shipping it back to the user. Question in the back.
Yeah, so when you encode your text into vectors, you use plain text. Is there an advantage to keep it as a JSON so there is context for the AI?
So the question is there an advantage I think if I understand, the question is there an advantage to using JSON as a basis for your vector embedding?
Right.
The answer is it depends. And for most, it depends on your use case. Like if you're doing semantic search, it's actually not better to use JSON. Because JSON is parameterized and it's structured, right? And you actually don't want structure, you want context and as part of the LM. But for other use cases, you do want to use JSON for less semantic type search. So because it just depends on the use case.
Thank you.
I'll take Richard and I'll get you. Yep.
So when you're doing that vector embedding, that's when you are sending your data up there?
No. I'm not sending any vectors up into anything. All the vectors are local. I mean, it could be local in some database in the cloud, but it's not.
Do the embedding.
Yes, to do the embedding, you send data up.
If you change those data,
You have to re-embed. You have to basically re-index. So the question is, if you change the embedding, do you have to redo the embedding? And the answer is yes, you do. Question.
Yeah, what engine is actually generating the cosine variance? Like when you get that variance, what engine are you using to actually generate the comparison?
So that's going to be service specific. And so if you use Pinecone, for example, as a service, they have their own cosine similarity. And cosine distance is not the only way you make comparisons, but it's one of the best ways for these high vector dimensions. And if you use OpenAI, they have their own thing. The thing is, you can actually write the cosine simulator function in FileMaker. In fact, we did it, and don't do it. It's slow. But in this example, when I rewrote this for native support with the LLM functions and scripts that are built in, there's actually a cosine. It's actually doing its own cosine simulator calculations with that script. Okay. How are we doing so far? I want to see more stuff, or you guys want? I'll take one more question, and we'll do some demos. Okay? Yep.
Earlier, you'd asked a basic question about arithmetic.
Yes.
And then you've been asking questions about specific information in this database. How does this tool know when to pivot?
That is such a good question. Repeat the question. So the question is this: how the heck? You didn't say this. How the heck did the tool figure out I was asking something about my database and not as a general question? All right. That's kind of magical, right? So it turns out this is where prompts. Remember I said you got 4 things you got to know. Prompts one of them, and prompts are super important. All right. So let me show you the prompt I wrote to do this. Again, my eyes need an upgrade, so bear with me. Chat name, right? So code. And I'm setting up a system prompt here. I'm going to release this file so you can tear it apart, but just understand that this is not production code. There's no error trapping. I don't give a whatever about any of that. It's just like bare bones, make it work kind of thing, okay? And so what I'm doing here is I'm actually setting up a default system prompt. And the system prompt is the message we say at the very top of our packet to the LLM, but how you want to deal with the rest of the questions and answers. User questions. And so check this out, all right? So I'm saying, hello, you are a helpful AI system for a program called Autoflix. Autoflix is a data set of some record count. So I'm interleaving some local data into this, generating a prompt dynamically. You'll try to answer users' questions using general pre-trained knowledge from the internet, or by returning the proper functions to the that was a typo, to Autofix for the processing. It didn't punish me for that, but you get the idea. Every time you want to answer a question, suggest some follow-up questions that user might want asking, and then use the following guidelines, blah, 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 blah. So this prompt, I had just kind of watched a couple times and tested it and refined it to kind of get it to behave the way I wanted it to behave. So just test it. But go ahead.
That looks like, is that something left over from using assistants and the tools? He's talking about the function.
We'll talk about it in a second. So the questions, what is this assistance and functions things that are left over? Actually, it's kind of a secret sauce to what you have to do when you want to work with local data to some degree, right? So what's actually happening here is that I'm saying, if this, do that. If it's something about Autoflix, do something else and give me a function back. What the heck is this function thing, right? So in OpenAI, and different LLMs call this differently, but in OpenAI, there's this capability called functions. And so what you can say is, what you can do is you can create a function that it's actually called tools, but the function is a tool that gives you the ability to return a computer function, programming function, back to your whatever system that you're calling. Right? So you can say, if you encounter this condition, send me the function that I need to use. Right? And this is like the underlying magic to a lot of the things that you're going to see from Ronnie and Claris, because they're taking a function back, and the function could be make a graph, query my database with SQL, do jumping jacks. Doesn't really matter what the function is. OpenAI actually doesn't know anything about what the function does. It just returns a function to you with the parameters that you have kind of defined. And then you use that locally, again, to do all the work internally. Should I repeat that?
Yes.
OpenAI is not talking to my database. It's just giving me back a response that I then can handle internally to do further work. Right? But it's smart about what responses and what tools or functions it can give back, because I've taught it to do that. All right? So you can imagine creating different kinds of functions where you do different things. If in this scenario, give me a search function. In this other scenario, do a, I don't know, shut down the database and delete all records. You could do that because you were actually controlling that operation, not OpenAI. All right.
Can we see an example of a function coming back and what it did?
Yes.
Or is that where you're going next, maybe?
No, but I can.
Oh,
Yep.
okay.
Yeah. You want to see what a function looks like?
Yeah, how it came back,
Okay. Well,
or what it looked like when it came back?
yes. We'll try. Let's see. My Zoom foo is terrible. Okay. So. This is. Do I have it?
I think it's only in the run steps.
Yeah, maybe in the run steps. So let's look at the code itself. So, blah, 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 blah. So perform a chat, and I say, I get stuff back, and I'm extracting the functions that come back. And this function's literally that string, extract keywords. It can be anything. This is not magic. You could be like foobar. You can name your functions whatever you want, right? That doesn't really matter. It's just a way for you to kind of do something with it, right? So I have another function called search autoflick. So this is literally, all a function is a name and set of parameters. And it's giving me back the name and a set of parameters that I can then just handle in my script. This is not the only way to do that. You can actually get OpenAI with agents and other LLM services to actually work on your database if you want. That's with line change and stuff like that. We won't get into that, right? But in the FileMaker space, this is one way to do it. Question?
So you defined that function in your prompt?
No, I defined the function at the service. So I went to OpenAI and I said, make me a function, it's called this. Okay, and it's called extract keywords or social autoflicks. Again, it doesn't have any data, it's just a function signature, essentially. It's just a structure. And it's just returning that instead of response. So it can return anything, but you tell it to return that instead of response. In fact, you can tell OpenAI, depending on the model you choose, to return things like JSON. So you can say, return this data in a JSON format. Right? So I can give you a bunch of data, it's messy, whatever, table structure, and spit it back out in JSON and do something with it. And that's a very common thing that you do. Let me get him in the back.
So with the function, is that an operation you do with every query, or is it, do you redefine that function every query, or is that you define at the beginning of the session?
You define, so the question is, do you define the function at every query or at every session? And the answer is actually, you define the function at the service, meaning it's part of your API account, essentially.
Okay.
And I saw another question over here. Yes.
I was just gonna say, one thing I've used is actually name this function by FileMaker script name, and then just perform script by name.
Yeah, why are you here? But yes, so you can actually name this function a FileMaker script name, and you can just using perform, script step was by name or whatever the function script step call is. All right, one more, Rich.
So,
Mark.
Yeah, that's okay. It's a common thing.
Yeah.
I guess it's not a challenge, I just want to clarify. You are sending, at least now, whether you're using an ETS version or using existing examples of insert from URL, you are sending your raw text to be embedded, to be vectorized, I should say. So you are sharing that at least with that function to give you the vectors back. But that's not being added to any library of information that's then vectorized and available to
I have no idea what OpenAI. So the question is this, right? In my example, I'm vectorizing my data using an OpenAI function. And Mark has rightly called me out on this. Like, well, dude, you just sent all this data to get vectorized. I mean, don't they have it? My guess is they do have it. But, they have dogs and cats, so I don't really care, right, in this case. The good news is you don't have to do that, right? You could do this embedding locally with a model that you spin up locally. Right, so
similarly with the search.
Similarly,
search queries themselves are also
exactly.
Intelligence potentially.
Exactly.
That could be added to that pool of data by the service, or you could potentially run that service locally.
That's right. And this is the takeaway here, right? So if you are concerned about data privacy and security, and you ought to be, because I have no idea what's going to happen with OpenAI, and nobody does, right? So this is all for convenience. But if you are concerned, then what you want to explore is how you do a lot of these things locally at your own hosting, on your own hosted instance, or a shared instance of some sort where you can kind of rent some, some protected models and whatnot to do that kind of work. LM Studio is a really great place to start if you haven't discovered it on the Mac. I think it's cross-platform. Good download. You can pull all kinds of models down. You can actually play with it and do local embeddings. And there's some cool stuff coming, I think, in ETS. I don't know when, but they'll let you do some of this stuff without.
Yeah, apparently it'll let us semantic search.
Well, okay. We have 1 more minute, and again, there's a lot here to cover, and this is sort of the tip of the iceberg. But hopefully this gets you thinking about what you can do with your system. 4 things you got to know: prompts. Well, what is it?
Vectors.
Vectors. Tokens. Models. Thank you.